Okay, let's try another example this time. So we have the center of this gear, and it is set to roll with a velocity of 6 meters per second to the right. And the gear rack B is fixed. So what are you finding? We're going to find the velocity of point A on the outside of the gear. Point A on the outside of the gear. So first thing you need to do is locate that instantaneous center of the smaller gear, and then calculate the velocities at point A. So pause, go try it on your own and see how it goes, and then you come back and we'll work on it together. So 3, 2, 1, and we're back. First off, we're trying to find the instantaneous center of zero velocity. Well, that's not too terrible because this small gear right here is connected to the ground. This block B isn't moving, and so this point right here on this small gear has to be 0. And the small gear, guess what? It's a part of this whole system. So they both have the same angular velocity. They'll both have the same instantaneous center. So we know what the velocity is at the center of my gear. We know what the distance is to this instantaneous center because that's just the radius of the small gear. And using some algebra, we can figure out what the distance is to this point. So first we calculate our angular velocity, which comes to be 20 radians per second, because that's 6 meters per second over a distance of 0.3 meters to the instantaneous center. And we use that angular velocity and our vector for the position vector from the instantaneous center to point A to get the velocity at point A, which is 6 in the I direction and 12 in the J, or a velocity of 13.4 meters per second. So that's it. The instantaneous center is an amazing tool, and I really hope that you go back and try out some of your other problems that maybe you've been struggling with. And hopefully it will help you, and I will look forward to seeing you all next time. Bye-bye.